right? And the jam session. But please remember that we'll have an amazing late-breaking demo session, and you really shouldn't miss that, okay? We'll have up to 60 posters tomorrow here. It's going to be dense, interesting. I know it's going to be difficult to wake up early in the morning tomorrow, but please be there, okay? Now, I suggest we move on to our session. It is my pleasure to introduce Dr. Rebecca Fibrink, who I'm sure most of you already know very well. Rebecca is a senior lecturer in computing at Goldsmiths University of London, where she is affiliated with the Embodied Audio-Visual Interaction group. She also supervises research in the Sound Lab at Princeton University, where she is an assistant professor. She was an assistant professor prior to relocating to Goldsmiths. She has worked with companies including Microsoft Research, Sun Microsystems Research Labs, Imagine Research, and ISMIR, where she helped to build the #1 iTunes app, T-Pain. Much of Rebecca's work focuses on applications of machine learning to music, as I guess will become very clear through the presentation, through the talk. She especially designs new ways for humans to interact with computers in creative practice. For instance, she is the developer of the Wakinator system for interactive machine learning. She's also an active musician. She has performed with a variety of musical ensembles, including as a laptopist, principal flutist, or keyboardist. She also has served as our chair for the Machine Learning from Music exhibition, which, by the way, is still running in the left gallery. There are a couple of very nice demos. I encourage you to go check them if you haven't yet done so. So, Rebecca, thanks very much for accepting our invitation, and the floor is yours.
Thank you so much. Can everybody hear me? All right, excellent. It's such an honor to be here. Thank you to the organizers of ISMIR for the invitation to come speak to you. I used to be a regular ISMIR attendee, and I count many people in this room to be my mentors and friends, and you're all often a huge source of inspiration for me in the work that I do, even though I haven't been here in a while. And today, my talk is going to largely be about using machine learning to support human musical practices, but it's a talk in 3 parts. And actually, the first part of the talk is why I'm not an MIR researcher, or not an MIR researcher anymore. And I mean this in the most loving way possible. This is not an insult to the MIR community, but I'm going to tell you a story, really, about why I haven't been here since 2008. So I began my graduate study at McGill in Ichiro Fujinaga's lab in 2004, and I really fell in love with music information retrieval immediately. Right? This is the early days before Spotify. I think Pandora was kind of around, but very, very early stages. And it was this exciting time where people had lots of data sets that were starting to be put together and available for researchers to use. Machine learning was really taking off. And we all had the sense that there were going to be some really fantastic applications just over the horizon of the work that we were doing. So I did a master's thesis around the topics of artist and genre recognition from musical audio. And afterwards, ended up going to Princeton for my PhD and studied with this fantastic guy, Perry Cook. Perry, of course, also published some very, very early work around music classification. And while I was at Princeton, I got involved really early in a couple musical projects. I became interested in working with the Princeton Laptop Orchestra, which at that point was about 15 people. Over my time there, it grew to about 40 or 50 people. And this was an undergraduate ensemble. It was a teaching experiment, and it was sort of a research laboratory where we could ask and explore questions like, hey, if we've got 15 or 40 people on stage and everybody has a laptop and the ability to control sound in real time and play something together, what do we do with that? How do we write music for that? How do we use this as a teaching tool? What do we want these students to learn from this experience? I also started working with really fantastic composers like faculty member Dan Truman, many PhD composition students at Princeton who were doing really fascinating experimental music with sensors, with different kinds of controllers. And very soon into this time at Princeton, I became interested in how I might merge these two worlds that I was interested in. Certainly, I was familiar with all the work happening at ISMIR at that point, and I was coming to ISMIR regularly. And I became interested in saying, hey, there's all this really cool research around audio analysis, around classification, around beat tracking, pitch tracking. And wouldn't it be great if we could put these tools in the hands of some of the composers I was working with, in the hands of some of the students I was working with? And so the last time I came to ISMIR was 2008. And I had a little paper that just shows the nuggets of these ideas. And it talks about my first effort at prototyping some music information retrieval tools that could be used by composers. And I did this at that time by writing some feature extractors and some really straightforward machine learning techniques in the Chuck programming language, which is a live coding language and also a language we used for teaching at Princeton. And this was kind of proof of concept to show that, yeah, we can run these things in real time, even in a very unoptimized environment like Chuck, and well, we have enough here to start experimenting. And as soon as I wrote this paper and saw that, yeah, there's a possibility here, I thought I knew what my PhD was going to be about. I thought I was going to explore and maybe start to answer the question of how can we develop MIR techniques that are better, maybe more accurate, faster, or otherwise more appropriate for musicians to use in real-time contexts. And in order to start answering this question with a little bit more rigor, I gathered around a lot of the musicians and composers that I had met in my time at Princeton and in New York. And I started doing what's called the participatory design process. And I was really eager to share with them the ISMIR 2008 paper that I had just written, show them the tools I'd written in Chuck, and try to say, hey, here's some of the stuff we can do with this fantastic research coming out of the MIR community. What do you think? And I thought that what I was going to get from that process was a better understanding of what needs to be more accurate, what needs to be faster, how do we change these algorithms to adapt them for the kinds of MIR problems that people in composition, say, really want to use. And I found out, actually, pretty quickly that this was not going to happen. And in fact, I learned, first of all, from this process, that I should have started with the question, what do musicians want to do with MIR or machine learning? Because it wasn't necessarily the way that I thought that the algorithms from this community were going to be beneficial. And so just to give you a sense of how I approached this with them, I brought in, again, that Chuck machine learning toolkit that I had just made, a bunch of other prototypes that I'd made, and started talking about MIR research and saying, hey, we can do things like get a bunch of audio examples, and we can train classifiers, and we can get those classifiers to label the audio, and we can label things about, hey, is this hair metal or trip hop, or is this Alice Cooper or Hooverphonic, or what's the tempo, or what are the chords, and so on. And maybe composers don't care so much about having an Alice Cooper label engine in their software, but there are all sorts of analogous, or very, very close problems that they might indeed care about, right? Is my saxophone player playing with a bright or a warm timbre? Are they playing part A or part B of my composition, right? These are undoubtedly useful things, and I thought that's what musicians would be interested in. But then I found out, well, yes, they are interested in that, and they're interested in a whole lot of other things. So it turns out that this was just one example of a whole set of problems where they saw machine learning as being potentially useful to them. We can think of making sense of data as something that's useful, but people also wanted to make sense of video, right? Making sense of data from the smartphones that they had, making sense of data from microcontrollers or on-body sensors, or even social media data. And composers had all sorts of things that they wanted to do with this data, but it was really hard to do. And they wanted to use machine learning really for the same reasons that people in this community were using machine learning, right? If you think about why were people 10 years ago using machine learning to do this at ISMIR, well, it's really hard, even if you're an expert programmer, to write an Alice Cooper recognizer without using machine learning, right? I don't know what that program looks like. If you think you know what that program looks like, I'd love to hear about it from you, but I think that's a pretty hard problem to solve just by thinking, no matter how much musicology training you have, no matter how much programming experience you have, it's hard. But if we have some data that can communicate to a computer, hey, here are the patterns that are signatures of Alice Cooper, then we have a fighting chance. And same thing with these musicians. A lot of the things that they wanted to do with all these different types of data were things that were hard to do with programming. And many of the people I was working with were indeed expert programmers. But machine learning gave them a possibility to extract meaning from this data, to label it in different ways, but also to do things that might look a little bit different from what we're doing here, right? Often in MIR, we are applying semantic labels, for instance, or there's this notion of there's some true way to label the data. Sometimes the musicians I was talking to were interested in that, but sometimes what they wanted to do was more, hey, just interpreting it in a way that was appropriate for a given piece of music. So a common thing they wanted to do was have some sensors that observed how a performer was moving and turn that into sound. And there's not a right or wrong way to do that, but they had opinions about how that might be done in the context of a particular piece. So I learned, okay, there's a whole set of things here where composers could really benefit from the kinds of machine learning that I saw happening in this community. And audio was just one tiny piece of it. So then the questions that I asked became, all right, well, what are the barriers preventing people from doing this? People had been using machine learning in music performance since at least the early 90s in the work of David Wessel and some other folks, but it was by no means widespread. Nobody I ever met at ICMC or NIME was using machine learning at all, maybe with the exception of David Wessel. And so I was interested in, okay, how do we make this more common? How do we allow people to benefit from these algorithms and do the kinds of things that they're talking about? And there's some easy answers here, right? For one thing, musicians aren't going to take the MATLAB code that some ISMIR researcher so graciously puts up on GitHub or whatever it was before GitHub in those days. MATLAB's not so great for real-time composition. So building things in real-time environments that connected with MaxMSP or SuperCollider or Chuck was an obvious way to start doing this. But that alone isn't enough. I was really inspired by tools like Weka, which a lot of people at ISMIR were using at that time, where you didn't have to be a machine learning expert, somebody coming from a machine learning research background to apply off-the-shelf algorithms to do fairly straightforward machine learning tasks. You could learn how to use a particular tool, and you could just get to work, right? You could get to the work of creating a good model and get on with your life. And I wanted to make a tool that felt like that for composers, where obviously you need some machine learning knowledge to use machine learning, but you don't need to have a PhD in it. But again, I realized pretty quickly that these weren't the hard things or even the interesting things to focus on when it came to enabling musicians to use machine learning more effectively. And there's some pretty hairy details here. I'm not going to get into all of them. Instead, I'm going to do a demo in a minute to help illustrate what I mean. But there are some big differences when you think about it in the types of modeling problems that people I was working with were interested in. Number one among these was the fact that a lot of the modeling problems they were dealing with, there was no ground truth data set, right? So if I'm going to build a new musical instrument that interprets some sensor data from something I'm holding or something I'm wearing, you can't just go on the internet and say, hey, give me that ground truth data set of people doing gestures X, Y, Z. Because maybe nobody has ever done those gestures before. And that shouldn't prevent me from using machine learning to recognize them, but it means that I have to make that data set. And often, the types of problems that people were dealing with, it was totally appropriate for them to make that data set themselves. If you're not trying to build a gesture recognizer for all of humanity, you might not need a large sample size with lots of different diverse people. If you just want to make something that works for you, all you need is data from you. And so I came through a long and confusing process of making prototypes, trying them out with musicians, seeing what worked, seeing what made sense to them and what seemed to get them where they wanted to go. Ended up building a tool with a process which in the HCI community, human-computer interaction community, we would call interactive machine learning, where instead of an ISMIR-like approach, where you really want to start with a big, good data set and create the most accurate models of that you can, the emphasis is on first giving users the ability to create good data themselves, enabling them to create a good model of that data set, but then allowing them to evaluate that model, and if something needs to change about it, enabling them to make that change, often through changing the training data. Right? So if this is something you've used, or if this is something you've read about, this might make perfect sense to you. If this is the first time you're thinking about this, this might seem really, really strange, because this is not how we usually do things if we're trying to make an accurate model of Bach chord transitions, for instance. You can't just change Bach because your model can't model Bach effectively. So I'm going to do a demo, and I'm going to show you a demo of the software that is the modern instantiation of the software I ended up building with those composers in 2008, 2009. And so this is called the Wekinator, and it's a tool for real-time interactive machine learning with sensors, with audio, with other types of data. So I'm going to give you two demos. These are classic demos. If you've seen me talk, you may have seen me give these before, but I think they're good illustrations. So the first thing I'm going to do is I'm going to build a really silly dance classifier just using my webcam. And so here I've got a 10 by 10 downsampling of my webcam, and as you can see, it's moving with me. There isn't a good ground truth data set of me moving in front of this feature extractor, certainly not on this stage wearing these clothes, and so on, but that's fine. I'm going to create a data set just right now for you, and we're going to build something that works. And I'm promising that without actually having tried that on this stage and under this lighting and so on. But I'm going to tell Wekinator to get these 100 features and use them to build me a music controller using a classifier. And we're going to control a really simple drum looping thing, if I can find it. All right. So what I'm going to do is create my data set first, and I'm going to tell it, all right, when I'm standing here, please make this sound. And so it's captured 25 snapshots of me standing here, and I can say, when I'm not standing here, please make that sound. And just from that, I've got 44 examples, and I'm going to run. I've trained it, and it's working pretty well. So I'm going to now try to find a place where it makes a mistake. All right, so that's a mistake. I'm going to add more examples to the training set because it hasn't learned what to do when I'm here. It's fine that it's making a mistake. I'll give it more data, and I'll retrain, and I'll rerun. And it seems to be doing better. And it's still doing that okay. And I can keep doing this and try to see if it makes a mistake somewhere else. There we go, that's a mistake. So I'll add class 1 there as well and retrain. And I can just keep doing this and adding data until I'm happy with it. Maybe when I'm happy with it, I say, I want to make this more complicated now, and I want it to recognize my hand. So there's some hand examples, right? So that's interactive machine learning in a nutshell, right? I'm doing a lot of things wrong. And this is, thank you. You're clapping for K nearest neighbor, by the way. We can talk about that later if you have any questions. There's good reasons for using that. But this is, by all accounts, this is a bad feature extractor. This is like the worst possible vision feature extractor. I have a tiny data set, and yet I've just built something that's useful. And I would feel good enough about this to use it in a performance if I'm using these clothes under these lights, and so on. I'm going to give you one more quick demo, and this demo is going to show you a little bit of a different approach that looks more like the way that most composers have used Wekinator. So you'll notice that the demo I just gave you was kind of fun. It was maybe more fun than watching me click buttons on my computer using the mouse. But the type of music that I was able to create is exactly the same thing that I could play just using my mouse and clicking on some stuff. There's a whole other set of things that composers want to do with technology. Unsurprisingly, lots of them want to make new kinds of music, music that isn't possible using a MIDI keyboard or a mouse, and so on. And so this demo, I'm going to use a leap motion, which is just getting data about where my hand is in space. And I'm going to connect this to my favorite synthesis algorithm. This is called the blowtar. And the blowtar has 9 parameters that I'm going to control in real time. So my task of making an instrument with the leap motion and the blowtar is really making a 15 to 9-dimensional mapping function. I've got X, Y, and Z of each fingertip, and I want to map these to sound in a reasonable way. So let's open up blowtar here, and I'll give you a little tour through the blowtar sound space. Maybe. There we go. So blowtar makes some fluty sounds, makes some weird sounds, and some nice growly sounds. So this is a great big sound space. It's a fun place to explore if you're a composer. But man, coming up with a 15 to 9-dimensional mapping function that is comfortable to play, that sounds good, that doesn't make you do embarrassing gestures in front of an audience, that's hard. So we're going to use machine learning instead. And just like before, we're going to start with no training data set. I'm going to build a training set on the fly. So let's say maybe I want this sound, and I want this sound when my hand's sort of here. I can add some examples. And maybe I want higher sounds when my hand is up. Add some examples, and I'll train and run. And here I'm using regression, using neural networks here, and I'm getting some nice smooth control, and I can make a little blowtar theremin. But why stop there, right? We've got theremins already. Let's do something more interesting. So let's, oops, stop running. Let's put in this sound. And I'm going to put in this sound when I make like a claw hand in the middle. And so I've added that to my training data, and I'm going to retrain. All right, so that's just a sneak peek at what you can do with blowtar. You can see why I like it. You'll notice here, again, I'm using 43 examples. It's a tiny training data set, but I've made something that's immediately quite fun. And I'm getting sounds out of this that I've never heard before, even though I give this demo all the time. And it's really enjoyable to explore physically that space, that control space that I've made from a few examples. And I can do the same thing I did before, where if I don't like something, I add corrective examples. If I want to add in a new behavior, I can add more examples on top of the ones I've already created to try to explore some new sound. And I just can iterate on that until I'm happy with it. So that is the blowtar. All right, so let me go back to my slides. And right, so in my first work with these composers, 2008, 2009, this is almost where we ended up. We ended up with a user interface that was much more clunky and buggy than the one that I just showed you. But that's essentially the tool that I ended up making in order to make people, to make a tool that was easier for musicians to apply machine learning to the kinds of stuff they said they wanted to do. So my next question was really, okay, what do musicians do with it? It's great that they say that this is fun, but how does this end up being useful in their practice? Why? What does this teach us about machine learning? What does this teach us about music composition? And these were really the launch point for the next 9, 10 years of my research career. I'm still interested in questions that have been informed by this starting point. So in part 2 of my talk, now I want to give you some research highlights. Some of these are findings that came out in an early form in my very first observations of composers using Wekinator. Some of them are things that have been sort of marinating over the last several years as I do other projects with machine learning or other projects doing participatory design with composers. And I've become really interested in general about, I would say, the fundamental questions here that aren't just about music, but are more fundamental questions about machine learning and data and how they can support human practice, and also about interface design. How can we enable creators to use data and machine learning more effectively? Is it about new algorithms? Is it about new interfaces? Is it about ways that we connect people and machine learning? And I think the answer is all of the above, but I'm going to give you some highlights that I think might be relevant for some of the things that you are doing. So the first highlight is answering this question, well, what do people do with it? A lot of the early users of Wekinator, and many people who are still using it, are using it to build musical instruments, to really unlock the expressive potential of sensors and build really weird types of musical controllers that give you weird music that you can't play with a piano or with a MIDI keyboard, and so on. And people, since, I would say in the last 6 years or so, have increasingly been using it to make art and to make games and do other sorts of hard-to-classify things. So I'll give you some highlights of that. Let me make sure my blowtar is turned off before I put the sound back on. Yeah. So the first excerpt I want to play for you is from a piece by a wonderful composer named Anne Heggie. And she is, well, I'll just play it for you. So the whole thing is on Vimeo. I definitely recommend you watch it. I picked this excerpt for a few reasons. First, it doesn't sound like what most people think of when they think of computer music. It's really lovely, it's beautiful to watch, it's beautiful to play. And when she was making this piece, it was really important to her that she have a particular visual aesthetic and a type of embodied interaction. She wanted people to be moving in a way that's reminiscent of a yoga sun salutation. And that's the sort of thing, again, even if you're a really fantastic programmer, it's quite hard to write a piece of program code in any language to say, all right, when someone moves through a sun salutation, I want the sound to unfold in this particular way. But using machine learning, she was able to give examples just like how I showed you and build this pretty easily. Another instrument I want to mention from one of the very first Wekinator users is Michelle Nagai's Martlet. This is a piece of wood that she found on the side of the road, and she was like, obviously I need to make this into a musical instrument. So she put like 25 light sensors in it, and she plays this by wearing it, standing under a spotlight, and then casting shadows over the bark with her hands. And it's an ethereal, beautiful sound. Again, it's on Vimeo. I'm not going to play it for you right now. But this is something similar to the blowtar example I showed you. It's just hard to make this kind of high-dimensional mapping function by writing code, but machine learning makes it easy. The last composer I want to mention is Letitia Tsunami. She's a pioneer in the NIME community, one of the first people to make gestural controllers for music. And she's been using Wekinator a lot over the last 5 or 6 years to make a variety of pieces. And this is her instrument called Spring Spire. And this is actually, it's got 3 metal springs suspended across a wheel. And at the end of each spring is an audio pickup. And the audio you're hearing here is not the sound of those springs. She's actually using audio just for a sensing input here. She's doing some audio feature extraction on these springs and using that to feed into Wekinator to drive the sound that you're actually hearing. So she's using audio to get really fine-grained information about how she's physically interacting with the system. So here's a snippet. So yeah, totally not a performance practice or sound that you can get with a MIDI keyboard. And I'll come back to her a bit later. As I mentioned, in the last few years, lots of artists doing weird things have ended up using Wekinator. This is one of my favorite projects. Someone made a webcam that uses Wekinator to classify whether there is a screen of any sort in your field of vision. And if so, it takes your glasses and makes them transparent. So you're not allowed to look at your phone or a TV when you're wearing this device. I've also used Wekinator a lot in teaching. This is one of my favorite student workshop projects. So this is someone who just spent a couple hours making something called a HiBot. HiBot uses the same sensor I've got here, the leap motion, to detect whether you're waving hello to it. And that's all it does. It just waves back at you. And I love this because, maybe this is not a good use of 2 weeks of your life, but this is absolutely a good use of like 2 hours of your life. Yeah, I think the current version of Wekinator is at something like 15,000 downloads. There's lots and lots of stuff on YouTube and Vimeo if you want to check out weird projects. Chicks on Speed has made some weird foot controllers for music. People used it in digital puppetry, a bunch of uses for people with disabilities, lots of weird, hard to classify stuff. This guy made a facial expression to internet meme mapper, and at least one person has started a company based on work that he prototyped with Wekinator. So this is called Voclia, and it's a commercial product that allows you to sing or beatbox into a microphone and then translate that into tracks in a DAW. So why are people using Wekinator for this stuff? Well, there's, again, an easy answer and then some more interesting answers. The easy answer, as many of you know well, is that machine learning is just often a theoretically better way to handle data if it's noisy, if it's high dimensional, right? You're going to get better results than if you had a human programmer write that mapping function or that model. But more interestingly, machine learning ends up being well matched to many of these people's creative aims and design processes. So that's what I'm going to talk about in the rest of this part 2 of my talk. So one thing I noticed with the early Wekinator users is that even though Wekinator took the time required to build a new instrument from maybe hours to days or weeks of coding and smush that down into maybe a few minutes or a few hours, people didn't spend less time building instruments. In fact, some people often spent more time building instruments. And the things that they were often doing were they would build something, and just like you saw in the demos, they'd try it out and say, what do I think about that? And they would change it, not just to correct mistakes, but to try out a different idea. And it turns out you can understand this as an instance of really good design practice. There's research about design and creative work in all sorts of domains, everything from music to making a painting to building a bridge or writing software code, where you often start out by making the thing that you think you want, and then as soon as you have the thing you think you want, you learn that maybe your idea wasn't exactly right. Or you make something and decide, oh, you know what, I could add this other feature that would make it even better. Well, building a musical instrument is certainly like this, and the faster you can make it to have it so that somebody has something in their hands that they're trying out, the better the ultimate product ends up being, and that's, again, true for any domain. And the fact that interactive machine learning allows people to make something really quickly and keep changing it just by changing the training data in many cases supports this surprisingly well. That's right, machine learning wasn't designed to do this at all. And of course, the way that we're treating data, if this is what we want to enable people to do with machine learning, the meaning of data has changed from the way that many of you think about data in your work, right? If you're coming from a machine learning background, you're used to thinking about data as ground truth, right? You get a big data set, and there's something kind of true in that data set, and you're using machine learning or modeling to pull that out and make that accessible to you. But in the instances I showed you, where you're using, say, Wekinator to build a new instrument, or you're using it to control a live visualization as somebody's playing, there is no ground truth per se, but the person is using the data to communicate their ideas and to communicate to the computer their intentions for how they want the computer to behave. And in fact, this is a great interface, right? It's a very natural interface. It's more natural than programming in many ways, even for people who are expert programmers. And this is especially true when people are trying to communicate aspects of embodied practice or tacit knowledge. So if I were, trying to get you to learn how a violinist moves, I wouldn't write you a mathematical equation, right? If I were going to try to explain to you how someone who's doing music mastering does music mastering, I'm not going to write you a mathematical equation or a long if-then-else statement, right? The most effective way I can teach you about that is to have you watch somebody, right? Likewise, if you're trying to build a musical tree bark controller, it's very hard. Even if you're expert at math and programming, it's hard to write down that function for how you want the light sensor values to relate to the sound. But it's really easy to demonstrate those things. So we can think about data as a really nice interface for people to communicate to the computer, something that complements the ways that we can communicate by writing code or mathematical functions or clicking in a GUI. And so when I interviewed many of the first people to use Wekinator seriously over longer periods of time and said, hey, why are you using this? At that point, it was really buggy software. It's not anymore. It's very stable. But I was like, why are you using this weird, buggy software to make stuff? And they kept on coming back to this. They said, the things that I make with this approach actually feel better to use. They feel more natural, or they feel more intuitive than the things that I've built before by writing code. And that's not because they're bad programmers. It's because data is a really great way to communicate something that's hard for you to put into words. Just a brief aside, this idea of how data can provide a foundation for computer systems that really deeply understand embodied practices is something that many of my students have gone on to do interesting projects around. My former PhD student, Reid Oda, who graduated last year, started running with this and found a really interesting path where he noticed that the data that's generated from someone who's playing an acoustic percussion instrument is something that we can model quite easily. We can capture aspects of people's percussion practice. And in fact, we can model this so well that if you're watching, say with a high-speed camera or even a Leap Motion, the trajectory of someone drumming, and we notice that you've gotten to the top and are about to go back down, we can predict very accurately when you're going to hit that drum and even how hard you're going to hit that drum. And we could use this, for instance, to make a prediction much earlier in time. And if I'm playing a drum in New York, we could even send that prediction about strike time and velocity to you if you're in Tokyo. And at the very moment that I hit that drum, your computer in Tokyo can synthesize the sound of someone drumming. And so this allows us to do latency-free remote musical collaboration, beating the speed of light, which is quite nice. My fourth point here, if we start thinking about data as a way to communicate to a computer, data actually enables more people to become creators in environments where previously you maybe had to know some programming or know a lot of programming. I've done a lot of workshops with kids, for example, and it turns out 8-year-olds can use machine learning no problem. It's pretty straightforward. I do want to mention deep learning briefly because that's the big subject of a lot of attention right now, and it's certainly relevant to the stuff that I work on, and I do some deep learning work as well. But a lot of the tools for creative, quote unquote, creative deep learning that have gotten a lot of attention are tools that use data in a different way, right? They're using data to kind of give you training wheels. If we train on, say, this neural doodle, if we train a neural network on art by a specific artist, then we can make it easy for you as a novice to make something that looks like that artist. You can do something in this sort of Microsoft Paint-like interface and then suddenly turn it into that. Or one of my favorites, Edges to Cats, allows you to make a pencil-like sketch with your mouse and then it fills it in with the most cat-like thing out there. And these are undoubtedly cool, and you can imagine lots of analogies in music where this might be super fun to play with. However, what I'm talking about with data is a little bit different, right? Because people can provide data themselves, and if we're able to model the data that comes from an individual, then that can become even more powerful, right? These kind of constrain you to be, making the same kind of filling in the sketch as everyone else. But a lot of my work does the opposite. It says, okay, what do you want to do? What kind of thing do you want to make that nobody else has thought of before? And so this has come into play a lot in some of the work I've done in the last few years with people with disabilities, people who might not be able to pick up a violin or a guitar and play it, but nevertheless want to make music together, want to do all sorts of cool musical things. And one of the outputs of this work is a piece of software I'm going to officially release in the next month or so, but you can download the early version now. If you have kids, whether they have disabilities or not, this is probably a fun thing to show your kids. But this allows music teachers, music therapists, parents, to build musical instruments for kids on the fly with a really simple interface. You can do things like turn real-world objects into controllers. If they have a favorite stuffed animal, you can make the stuffed animal dance around and control some sound samples. I've also been exploring this in work outside of music. Oh, by the way, I want to give a shout out to Hugo Squirto, who's showing one of the things in the exhibit out there. He worked quite a bit on this, and he will be happy to talk to you about his PhD work, which is a little bit related. So I'm doing work outside of music as well. I've got a collaboration right now with Microsoft Research where we're thinking about data as opposed to, say, speech or programming or other types of interfaces, data as a really good way to enable personalization of systems. And we're focusing on developing systems for people who are visually impaired and helping them to make sense of what's going on in their social environment. So for instance, is there somebody who just came in the room in this crowded space who's actually a friend of mine and maybe I want to know that they're here? And I'm becoming more interested, again, in this idea of data as something that allows people, no matter their background, to communicate something meaningful to them, to allow them to exercise more control or customization over technology. And this, of course, is very, very different from the way that we've been talking about data in our society in the last year or so, right? I think most people's experiences of data and machine learning at the moment look, like they're related to this, right? They might experience machine learning as something that is done to them. They might experience data as something that is collected from them with or without their consent, and they may not really benefit from that process, but somebody else is making a lot of money off of it. And so one of the things I've been thinking about a lot recently, and which surfaces in different projects in different ways, is, it'd be great to allow people in general, in different contexts, to get more value from their own data. Data is something that we can use with intent. It's something we can provide willingly, and we can get a lot of value from it. If we think about this as really, this is providing information about what I like or how I want to work, and so on. So I think there's a lot of room to explore different ways that are maybe more empowering for using data. And then the last point I want to mention in part 2 of my talk is this, that machine learning can open up new creative roles for humans and new relationships with machines. And again, many of the composers and artists who I've worked with, this is foremost among their goals. They don't want to make the kind of art that you could make with a paintbrush. They don't want to make the kind of music that you could make with a piano. They want to do something else. Or they want to be taking on a different role in that process. Now let's go back to Edges to Cats again for a bit. So Edges to Cats is actually one of my favorite creative tools on the web right now. And it's not because I want to go home every day and draw a more realistic cat. Like, I don't think there's ever been an artist who says, I really, the thing that's missing in my life is the ability to put in photorealistic fur and an indeterminate amount of eyes on a cat outline. But if you go to Google Images and you search for Edges to Cats, it's beautiful, right? People really just run with this. And a lot of creative work with deep learning on the internet looks like this in some way. It's people exploring and exploiting ways that these algorithms break down. You might know Janelle Shane's work with text. She does things like paint color name generation or South by Southwest band name generation. Same kind of thing, right? People saying, hey, here's a machine learning algorithm that we can tweak a little bit to do something funny. And so I think these are art. They're not serious art, but this is creatively satisfying work for a lot of people because it pairs human ingenuity with machine generation in a really lovely way that appeals to people. As a counterpoint to this, there is, of course, a lot of serious work using machine learning, and one of my favorite artists is Mario Klingemann, and he's been interviewed a lot and talks about the way that he makes visual art with neural networks, and talks about how his position in the art-making process is changed, right? He's not using Photoshop and deciding what colors go on which pixels, right? He's actually spending a lot of time acting a lot like a computer scientist, writing algorithms, and then seeing what they do, and then running them and running them and running them, and acting like a curator, and finding which images appeal to him, right? So that's a different kind of artistic role than someone who's painting with a paintbrush. I don't think you can say it's more or less creative, but it's certainly a different way to be creative. And if you read any of the things that Letitia Tsunami has written or said about her own work, I think she's got some very interesting things to say as well about the creative value of machine learning for her. Yes, she's interested in the things that I mentioned, of having rapid prototyping and exploration be easily available. Yes, she's interested in having embodied practices be, more easily a part of how she interacts with the computer. But that's not the whole story. If you look at what she's saying here, she says, you don't want the instrument to perform like a well-trained animal circus. You kind of want it to be a little wild. You want to adapt to it somehow, like riding a bull. And I like this, right, because this sounds fun. And she thinks this is fun, and this is part of her creative practice now, and this is one of the reasons she likes machine learning. It's not because the machine is doing all the creative stuff, but it's also quite different from the way we usually think about how we want to interact with machines, right? Most user interfaces are created with the assumption that people want to control them, that we, as the great humans, know exactly what we want, and we just need an interface to express that as efficiently and accurately as possible. And what Letitia is saying is that, no, I'm not as interested in that. There's other ways to make art. There's other relationships that I can have with technologies that might be more interesting. If you remember the blowtar demo, right, it didn't take a lot of work for me to make something that felt like I was learning how to play it at the same time that it was learning what I wanted. And I found some new sounds and had a lot of fun because I made something that wasn't just the best idea I had in my mind. All right, so to finish off this section, I want to recap the way that I think about machine learning as a good tool for human creators. So it makes it possible to work with sensors, with audio more effectively. It supports rapid prototyping and exploration, meaning that the thing that you get at the end is something that you're likely to be happier with, no matter what that is. Data itself, we can think about it not as ground truth that we collect from the world, but as a way for people to communicate ideas and intentions, and especially to communicate things that might be hard for them to articulate, like embodied practices. Machine learning enables creation and personalization by more people, and the thing I'm really excited about at the moment is that it opens up new roles and relationships between creators and technology. So I want to finish up with part 3, which is just some reflections on collaborative and user-led research. So ever since I did that first participatory design project with composers in 2008, I've continued to use that same kind of process in other projects, and I've often found similar outcomes in that, my ideas change over time, and I end up feeling like I made something more useful, more interesting. A couple of projects that might be interesting to folks in this room are Rapid Mix, a project in collaboration with IRCAM and UPF that we just finished up last year. One of the outputs of that project is a set of developer-facing machine learning tools for developers who, like Wackonator users, might want to be working with real-time audio or sensor data, but they might not be machine learning experts, and machine learning might not be the core thing that they care about in the app, but they want to make something that works. Most recently, I've just begun a project with many collaborators in the UK called Mimic, and here we're going to be making some web-based deep learning tools for musicians and composers. I wish I had a web page to send you, but I don't yet. And I've also done this kind of collaborative design, participatory design in some digital humanities work. I made a really fun interactive version of a 13th century multimedia manuscript from France. This project's called The Digital Fauvel. So if you're one of the people at ISMIR doing early music work, I'd love to talk to you about this project and where it's going. Now, participatory design, it's not magic, and in the immortal words of The Who, it's hard. There are a lot of really, really hard things involved in working with users the way that I often work with users. It's hard to evaluate whether something works or not. You can't just run it on your server and come back in the morning and see whether you've got 90% accuracy instead of 88. It's difficult to understand whether something's actually solving a problem or not. It's difficult to make projects that users will use, right? You have to make it a little bit more robust and a little bit more usable than if it's just a piece of research software. And it's hard to support software like Wekinator when you can't really get a research grant for doing bug fixes, but you have to fix bugs anyway. And in the work I've been doing with kids lately, my stuff gets drooled on a lot. I have to literally wipe saliva off of my equipment all the time. I never thought I would find myself in that position when I was working in a Cheerios lab 10 years ago. But the hardest thing about participatory design and work with users, in the immortal words of Weird Al Yankovic, is that everything you know is wrong. Everything I know is wrong. Almost everything I know has always been wrong. And working with users is a constant process of, if you're doing it right, finding out that all your assumptions are the wrong ones, all your solutions are the wrong ones, and you need to listen to people telling you that you're wrong a lot. And to confound that, users are often wrong too, right? Everybody's wrong. If you take an HCI course or you start looking at HCI research methods, one of the first things you learn is that you can't just ask somebody, hey, what technology would you like? Or, hey, well, do you think you'd like to use this thing I made? The success that I've had in making things that are useful to real people has, I think, more than anything been the result of really long, intense collaborations where it's not just me building a thing and doing a lab study and saying, hey, they liked it, so it works. It's been involving people in the research process and saying, hey, here's a prototype, what do you think? Having them try it out, doing some brainstorming together, going back, bringing back another prototype, trying it out. Because just like building a musical instrument, right, having a new piece of software or hardware in your hands as a user is going to help you understand the design space, and it's going to help you understand the solution space better. And so, of course, this is really difficult, but I don't know how else to do it, and I'm still doing it because at the end of the day, if you do it successfully, it can be really gratifying. So making something, in my experience, making something more accessible to new people often leads to unexpected uses, totally unexpected, unanticipated insights, and then new research questions. And so that's why I'm still kind of following this path that I began about 10 years ago. And of course, almost in the immortal words of REM, you have a lot of happy people. And that's fantastic when you make something and somebody says, you know what, this allowed me to do something that I couldn't do before. And this has been informing another vein of my research in the last few years, which is not just making technology more accessible to people, but making education more accessible to people, specifically teaching more people about machine learning. I have a course on Cadenze, which you can take for free or send to your students, called Machine Learning for Musicians and Artists. And it's a first exploration of how we might teach a lot about machine learning to people who are not computer scientists, may or may not be programmers, may or may not want to see a lot of math, but nevertheless have really interesting use cases. And this has become increasingly a focus of my research. And again, I think it's relevant to a lot of work outside music, outside the arts. I think we're in a moment where more people should be learning about machine learning, what it actually is. That the singularity may not be imminent, but there are a lot of other really important questions that they need to be capable of engaging with. So on that note, I'll leave you with two questions. First of all, who might want to use the things that you are making? Especially those of you who are researchers and not at a company making things for profit. How might your work, maybe the work that you're presenting here, enable more creativity or access or discovery or fun? And you don't have to start big. You don't have to found a company and quit your academic job. But even starting really small and making a little prototype and seeing what people might want to do with it is often a really good point to begin. And so try it out and maybe it'll go well, and maybe you'll never come back to ISMIR, and I won't see you. But maybe you will. So thank you very much. I'm happy to take questions. I think we have maybe a couple minutes. I don't know. Slim can tell us. Thank you.
We have 5 minutes for questions. Wait for the microphone, please. It's coming.
Hello. So I'm imagining the restaurant or the retail environment of the future where people's positions in space, or like the density of people or the amount of energy they have in their bodies could affect the music that's playing in the space. Is this something that you've thought about or that people are maybe working on?
I have not thought about it or worked on it. Certainly the sensing technology is there to get a lot of information about what people are doing in space. Yeah, I think it sounds fun. I bet there are a lot of people in this room doing things like music generation in social contexts who would have, a lot to say about that.
Thank you.
Thank you for your presentation. A lot of the work you presented is related to HCI, but in the early days, Building Instrument was involved in being able to play the instrument, but also was about finding the right sound texture that the instrument player wanted to have. Is there work or people you know which are also working on this side of, let's say, digital musical instrument making? Or is there more HCI exploration where you kind of discover new timbre as you go?
So I didn't hear all of your question. I'm going to try to answer it. If I don't answer it correctly, you can repeat part of it. But certainly, I find that in the HCI community, there tends to be a lot of really great broad discussion about how these issues pop up in other domains where people are either creating things with technology or people are trying to use machine learning as, say, people with real-world applications. Whereas the place where I see the most inspiring work around sound exploration, new musical instruments is absolutely in the NIME community. And there's been plenty of machine learning and non-machine learning work there. So that's my first stop for that. I don't know, is there a more specific part of your question that I didn't catch?
Yeah, it was mostly related to really sound synthesis, using machine learning for doing sound synthesis to manipulate explicitly the timbre of, whereas from what you presented, I saw a lot of HCI related things. So I wanted to know whether there was a community working on that and if you had people or examples.
Yeah, I mean, there's certainly lots of work around synthesis. Much of that is not so user-facing, but some of it is, right? I think, the DAFX community, for instance, the Google Magenta project has done some really interesting tools, like user-facing tools over the last year or so to do deep learning-based sound synthesis, and I think they're just starting to scratch the surface and saying how we make interfaces for people to explore in a useful way in a composition or production or performance context. But there's absolutely lots more that people can do.
Thank you.
Thank you for the thought-evoking presentation. So I very like your first demo where you map the gestures to the sounds. I think the users define that mapping. Now let me think about how users play traditional instruments. Let's say we play a string instrument, and I make, say, I plug the string, I produce a sound. And if I bow the string, I produce another sound. This is another kind of mapping this mapping follows the physical laws. In your demo, the mapping is defined by the user. I think for musicians, sometimes I feel it's fun to learn the mapping by kind of exploring the instrument and the playing gestures to explore the physical laws that I'm kind of playing with. I'm thinking, do you think it's also possible or interesting to design the system systematically, to design some kind of laws in the system? It's kind of like an alternative world there in the computer. And then the user can explore those laws by interacting with your device.
For sure, yeah. So I haven't done any work around that, but someone's work who I really enjoy is Ed Berdahl, who has been publishing a lot in the NIME community. So he's made some really cool tools that are based around physical modeling, but allow you to reconfigure physical models, often with haptic physical systems on top of them that are just super fun to pick up and explore. And they have these, properties that you want to find out in a hands-on way. I don't think he's been pairing that with machine learning, although I think there are cool possibilities there, yeah.
Okay, thank you very much. Let's thank our speaker again.
Yeah.
And we now move on to session F, which will be chaired by Emilia Gomez.